All right, so section 01. We don't start at chapter 1. This book starts at chapter 0 because this is kind of like a review of algebra and some basic principles that you're going to be using all year. Remember we talked about this yesterday, that this geometry course, it's called geometry, but there's a ton of algebra in it. There's a lot of algebra in it. All right, so that's what we're going to take the next week or so to go over to make sure that you know how to do this algebra. One of the first things they talk about is this unit of measurement. Okay, we're going to start with the metric system. There's a metric system and the English system. So today we're going to talk about both of them. But first of all, we're going to talk about the metric system. So here we go. Some people call this a kilometer, but most people would say it's a kilometer. We kind of shorten it like that, or just kind of make it flow a little bit better like that. We call it a kilometer. Now, a kilometer is a pretty long distance. If you look at it, it's 1,000 meters. Well, what's a meter? Well, this stick right here, this is not a yardstick. A lot of people think it's a yardstick. It's not a yardstick. It's a meter stick. This is 1 meter long. And people say, well, it looks like a yardstick. Well, if you turn it around, this is in inches, and this is in centimeters and millimeters and all that kind of stuff, this side right here. But if I flip it around, this is 1 meter. How many inches would 1 yard be? If I went 1 yard, how many inches would a yard be? Somebody know off the top of their head? 36, okay? How many, Daniel, how many does this go up to? It goes around 39, a little bit more, okay? So 1 meter is actually a little bit more than a yard. So I'll put my fingers here, right there. See where my finger is right there? From here to here is 1 yard. So about that much, about a little more than 3 inches more than a yard is 1 meter, okay? So a meter is pretty close to a yard, but that's how long a meter is. If I took 1,000 of these, okay, if I went end to end, 1,000 of these meters, 1, 2, 3, 4, all the way up to 1,000, I would get 1 kilometer, okay, or kilometer. But most of the time, people that say this word usually say kilometer and not kilometer, all right? So you measure long distances with this. If you look in your car, look on the speedometer in your car. It'll tell you miles per hour, but if you look, it's a little subtle. Usually it's in a different color, maybe a little smaller. You'll see a km per hour. Okay, that means kilometers per hour. So you measure longer distances with kilometers. A kilometer is quite a bit shorter. It's just a little more than a half a mile. Okay, I think it's like 6/10 of a mile if I remember right. So a kilometer is just a little bit more than half of a mile. So a mile is quite a bit longer, but kilometer is still pretty long. It takes 1,000 of these meters to make 1 kilometer. What's that? You're just gonna have to wait. All right, so there you go. Let's talk about centimeters. Let's go back to that stick again. That meter stick. Let's talk about centimeters. If you look at this, now I know it's kind of dark in here, but the people in the front row can see it. You can see the big numbers. You see it's 1, 2, 3, 4, 5, 6, and it keeps on going, keeps on going, keeps on going until you get to, what do you think? You don't see the number. What do you think that last number would be on there? Well, it's not right. There's 99, and then what do you think it goes to? 100, that's right. So each one of these smaller lines, when you see that 1, 2, 3, 4, 5, you can probably even see that in the back, can't you? Just barely. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It keeps on going, keeps on going. So that distance, I'll put my fingers about that wide apart. That distance right there is a centimeter. It's a centimeter. Why do you think they use the word centa? Where does the C-E-N-T? What do you think C-E-N-T means? What's that? Okay, a centipede is a word that uses the cent, the prefix before it. But where do you think the actual cent comes? It's 100, right? It's 100. Give me another word that we, I don't know if you use it every day, but that you use probably, I don't know how often you use it, but you probably use it quite often. Like if you talk about years, what is it? A century. That's right, a century. Okay, whoops. Oh my goodness. Forgot to change this thing up here. I got to change this to be able to write. There we go. All right, so a century. Why do we call it a century? Well, cent is a prefix, okay? Whenever you see the word cent before it, it usually means 100 of something, okay? So century means 100 years. Somebody said centipede, all right? Centipede. Now, I'm not sure if it exactly has 100 legs, but I think that's kind of like a generalization. I've never counted them. Don't see too many centipedes around, but supposedly it's 100 legs, okay? So it's 100 whenever you see that. So what does that mean? It means 100 of these things makes up 1 meter, all right? So 100 centimeters. Look on the meter stick. There's 100 of those lines. It makes 1 full meter. Now there's some other lines. Now you can't see this until you get really right close, really close. Oh, you know what I have? I'll tell you what, let's actually have, oops, I actually have a little ruler deal here. Look at that. That was convenient, wasn't it? So look at this. I've got inches and centimeters, but look at a centimeter. That would be a centimeter right here. But look, and they've numbered. See, there's 0, there's 1, 2, 3, 4, 5. That would be a centimeter. Look right here. Look at the little tiny lines in between. How many of those little tiny lines between the 0 and the 1? There's 10 of them. Okay, I know it's hard to read because they're kind of squished together, but there's 1, 2, 3, 4, 5. See, they put a little bigger line there for the 5, and then 6, 7, 8, 9, and then when you get to that real big line, that's 10. There's 10 of those things. So look, that's what this is right here. There's 10 millimeters. Milli, M-I-L-L-I, is a prefix for, what do you think? Not for 10, but what? Not a million. 1,000. That's right, because think about it. If there's 10 millimeters in 1 centimeter, how many centimeters are there in a whole meter? They're not all listed here, but how many? How many centimeters in a whole meter? It's up there. It's up there. 100, right there. 100 centimeters in 1 meter. It's right there. So if there's 10 millimeters in a centimeter, right? So look, one of these things got 10 of them in there. But how many of these centimeters in 1 meter? 100. So I go 100 what? Times 10. What's 100 times 10? It's 1,000. So there's 1,000 millimeters. In fact, let's write that down. They don't put that in this little box right here, but let's do that. So 1,000 millimeters equals, what does that equal if you have 1,000 of those really tiny little lines? 1 full meter. So if you look at this stick again, this meter stick, there's these little lines, and you can't even see them, especially if you're in the back, even just a couple rows back. It's all kind of blurred, looks like one little blurred line right there. But there's tiny, tiny little markings in there. There's 1,000 of these. I got to count up 1,000 to make up this whole meter stick. All right, so that's what we have here. It wasn't on this original list, but 1,000 millimeters equals 1 meter. All right, those are important things. Now look, the cool thing about the metric system is that all you got to do is remember some basic prefixes. If you know these prefixes, when I say a prefix, I'm talking kilo, that's a prefix. The milli, prefix. Centi, that's a prefix. That means it's a number, it's a word before the meters. You see it? Kilometer, centimeters, millimeters. These are the numbers before the word that represent something. It tells you how many of something you have. You have milla means 1,000. Centa means 100. Okay, kilo actually means 1,000, but the milli means 1,000 parts, 1,000th of something. If I took a whole meter and I split it up into 1,000 parts, boom, 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 I chopped it up, really little tiny pieces, and I got 1,000 of them. Each one of those pieces is a milli. All right. Let's say I had one big old kilometer, like one big meter right here, and I multiplied that by 1,000. What if I had a whole bunch of these meters? Then I have a kilometer or a kilometer. The cool thing about this is these things aren't used just for meters. They could be used for other things. For instance, we can measure the weight of something. For instance, like grams. All right, that measures the weight of something, and that's in the metric system. So if I said I had a centigram, what does that tell you about this gram? It means we took a gram and we split it into how many parts? 100 parts. That means what? 100 centigrams equals 1 gram. That makes sense, doesn't it? If that makes sense with the unit, with the length, it makes sense with the weight of something. All right, we could use that all the time. I could go milligrams. I could go. Let's do this. Let's put 1 gram. How many milligrams is 1 gram? 1,000, right? Because milla, all you got to do is remember the prefixes, right? If you know what milla or milli means, then you know how many milligrams is 1 gram. There would be 1,000 milligrams, mg, milligrams in 1 gram. If you go to the store and you buy stuff off the shelf, boxes or canned goods or something like that, they usually tell you the weight of it. They tell you like how many ounces or how many pounds or how many pints or whatever. But then in parentheses, a lot of times they'll tell you how many or what your metric system is, how many milligrams or how many grams that particular thing is. And I think I forgot to do this in my last class, so you guys are special. Look at this. I've got these. This picture's right here. Let's just drag this over, and let's drag this over right here. Alright, and who hasn't gotten that list yet? If you haven't signed that book list thing, you know, to tell what's wrong with your book, make sure you get it before you go. Alright, look at this thing right here. Now, I don't know if you'll be able to see this. Let me see. It might be a little blurry if I... Oh, there it is. You can kind of see that, right? What does that say? 12 what? Fluid ounces. That's right. So that's kind of telling you how much of this stuff you have. But right after it, what does it tell you? 300, I don't know what that number is, 65 maybe, something like that. Then ml, what is that? It's a milliliter. Okay, that's how many milliliters. Well, what's a milliliter? It takes how many milliliters to make 1 full liter? It takes 1,000 of them, okay? This is about 360, so it's about a third. This 12 ounces is about a third of a liter, all right? Look at this right here. I thought I wrote this down, maybe, I don't know. This says... Well, this is a 2 liter, and it's, I think, yeah, I guess that's a 2 liter. But anyway, it's hard to read. Sorry, I thought you could read it a little bit better. But it tells you how many, yeah, it's 2 liter, it tells you how many ounces, and tells you how many quarts and all that kind of stuff. All right, and if you look at almost every item you get, you'll see sometimes it's in metric, like this one right here. They tell you right off the bat. I mean, you look at a 2 liter bottle, you know exactly how big a 2 liter bottle is. So we're used to seeing 2 liters all the time. You know, if I said 64 ounces, I don't know, you may not be able to have a good feeling of what that means. I don't know, you go to 7-Eleven, don't they have like the big gulps and all that kind of stuff? You know, you get a 20 ounce, you get a 32 ounce, you get a 64 ounce or whatever. But sometimes liters is a lot easier to use. Okay, I think this is a 1 liter, right? You ever buy a 1 liter? Okay, there's a 2 liter, and that's I don't even know how many liters that is. But we're used to liters, okay? We're used to that kind of stuff. It's just a matter of using it all the time. For some reason in America, we just don't use it. Okay, what's another thing? We talked about this a little earlier. Let's drop this down a little bit. Put this on here. Look at this right here. What in the world's that number right there? 70. Why would they put a 70 right there? That's right, it's kilometers per hour. Now I know this picture was just off the internet, but you can see it right there, can't you? See, km and then a slash and an h. That means kilometers per hour. Now, in the States, we just put a 45. Everybody knows what that means. It's 45 miles per hour, 40 miles per hour. But in other countries, ones that maybe are converting over or kind of use both systems, you'll see that. But I tell you what, most countries, like in Australia, I lived in Australia for a couple years. That's why I got a couple of the Australia stuff. It was a long, long time ago, way before you ever thought of it. It was in 1973-74 is when I lived in Australia. I was 8 and 9 years old. They were just at that time, this is 73-74, they were just getting ready to convert over into the metric system. They were just like in the middle of it. So sometimes you saw speed limit signs like this, but most of the time you would just see a 70. It wouldn't say 45 and 70, it would just say 70, and that's all it would say. Right? A lot of times you saw 100. Right? Does that mean you can go 100 miles an hour? No, it's 100 what? Talk to me. Kilometers. Let's say kilometers per hour. All right, that's the kind of stuff that you would see. In America, don't know why, we just haven't converted all the way over. I think we're about the only country that has not converted completely over to the metric system. In Canada, it's the metric system, okay? Except for a few things. Now they do play football like American football. Well, I don't think they call it American football. They probably call it gridiron. When I was in Australia, they have a sport called Australian football, which I used to play for about 3 years. It's not rugby. Everybody says that, but it's not rugby. It's called Australian rules football. And maybe like when we have a day before a break or something, I'll show you some videos and I'll show you some Australian rules football. And looking at me and watching these guys, you'll probably think, I can't believe Mr. Hamrick played that sport. But it's a cool sport. I mean, it's really, really a cool sport. But in this sport right here, they call it gridiron. Look at this. This is a Canadian football. It's not 100 yards long. So 50-yard line is not right in the center of the field. They have a big C right here. But even in Canada, you go to the stores, you buy gas. They sell it by the liter, not by the gallon. You look on the roadsides. Their street signs are kilometers per hour. Everything they do pretty much is in the metric system. But they still stick with yards in their football. Okay, this is still in yards. It's not meters. It's not the 10-meter line. It's still in yards, even though it's in Canada. But isn't that crazy? They have a center line, then they got a 50 here and a 50 here. So it's a lot longer field. They have one less down, and their end zones are a lot bigger. I think they're 20 yards in the end zones, which means there's a lot more scoring because there's a lot more room in the end zone you got to cover. You can imagine being a defensive back in the Canadian Football League because you got a lot more room to cover, a lot bigger field and a lot bigger end zone. And look where the goalposts are. The goalposts are actually right at the beginning of the end zone. That's like old school American football. They used to do that back like in the 60s. I think they changed it, 60s or 70s, where they pushed the field goal to the back of the end zone. But people used to run into the goalposts all the time. And anyway, there you go. What does that have to do with math? I don't know. It's just interesting stuff. All right, so what are we going to do with this stuff? What we're going to do is we're going to do some conversions. We're going to convert from one to the other. We're going to convert. If I told you, you know, this town was so many kilometers away, and you wanted to find out how many meters that is, that's what you want to be able to do, and vice versa. So let's give it a blank spot right here, and let's try one. Let's try 4.2 kilometers. This example is in the book, but write it down anyway. Everybody should be writing this down. So 4.2 kilometers, what I'm going to do is I'm going to convert. I'm going to change it from kilometers. I'm going to put an arrow just to represent what we're changing it to. 2 meters. This is about as easy as these get. 4.2 kilometers, and I want to change that to meters. Find out how many meters is 4.2 kilometers. Some of you guys can just look at it, know how many meters is a kilometer, and then just do it in your head. But I want you to do it this way just to get in practice, because sometimes they get a lot more complicated than this one. First thing I do is this. Oh, you know what I got to do? I forget that. Let's go back in time a little bit. Let's go back when you're a kid. I don't know what grade you're in, maybe 4th, 5th grade, something like that. You learned about fractions. And let's say you had 2 over 2. What does 2 over 2 reduce to be? Reduces to be a 1, doesn't it? It's not 1 times 2. It's just the number 1. What if I had, like, I don't know, 27 divided by 27? What does that reduce to be? 1. So basically your teacher used to tell you what? Anything divided, what did they say? By itself is equal to what? To 1. Let's go letters. Let's go A. A over A. What's A over A equal to? Follow the pattern. Anything divided by itself is equal to what? 1. 27 over 27 is 1. What's A over A? A could represent any number. But if I divide it by itself, I'm always going to get what? A 1, not an A. Everybody wants to say that. My last class, a lot of people said that. Okay, it's not an A, it's a what? It's a 1. Anything divided by itself is equal to 1. Not 1A, just the number 1. So for instance, if I had this, I'll get real algebraic on you here. What if I had that? What's that equal to?
1.
It's just a 1, isn't it? It's not a 1x, it's not a 1y squared or 1xy squared. It's just the number 1. Watch this. I'm going to blow your mind now. Watch this. What if I had kilometer over kilometer? What's kilometer over kilometer equal to?
1.
It's 1. That's right. Okay, now I'll really mess with you. What if I said this? What if I said 1,000 meters over 1 kilometer? What's that equal to?
1.
Why is it equal to 1? I got 1,000 and a 1. How's that a 1?
1 kilometer. The same thing as 1.
Because it's the same thing. That's right. Because they're equal to each other. You're right. They're the same thing. So anything divided by itself, this is itself, isn't it? Because it's equal to it, right? Anything divided by itself is equal to what? 1. Not 1 meter, not 1 kilometer. Just what? The number 1. Everybody getting this? Okay. Now I'm repeating myself a lot because I know in the past people have struggled with this a little bit. So with all that said, okay, all that was just a side note. What I want you to do is come over here and see what we're going to do, and hopefully this will make sense. By the way, we call this a unit. Anybody know Randy Johnson, baseball pitcher? He was like, what, 6'9" or something like that? Maybe even taller. He might have been like 6'10". He's on that commercial where he throws the snowball at the guy and it wings him. And you ever see that? He was a real famous pitcher, one of the best pitchers ever. He was really great pitcher. Well, anybody know what his nickname was? Nobody knows? It's a little old. A few years back, people would remember, but he's retired for a while now. They call him the Big Unit. They call him the Big Unit because he was number 1. He was the number 1 guy, all right? And that's what they call him, the Big Unit. He was like 6'10". He was humongous. Well, tall anyway. He's real skinny. But they call him the Big Unit because he was what? Number 1. He was the #1 guy, and that was his nickname. So this thing right here, it's equal to 1. We call that a unit. And what we're going to do is we're going to do some multiplication with this. So we call these things unit multipliers. Write that down somewhere. We're going to use unit multipliers. Jot that down. So here's what we do first of all. I'm going to take what we're working with, and I'm going to always put it over 1. Now if I just put something over 1, it didn't change it, did I? It's just the same number. All right. But what I'm going to do is I'm going to multiply it by something to get rid of the kilometers and change it to meters. Now look, think about fractions. If I have a kilometer on the top, what I'm going to do is I'm going to put kilometer on the bottom. Now why in the world would I want to do that? Because they're going to cancel out. Exactly right, right? The kilometer and the kilometer will cancel out because it's the same thing on top and bottom. But what do I want to change it to? I want to change it from kilometers to what? To meters. So where do you think I'm going to put the meters? On the top. Very good. So do that every single time. Always put it over 1. Put a multiplication symbol, which I like to use the dot. Don't put an X. Okay, put a dot. And then what are you trying to get rid of? Kilometers. So you put that on the bottom. What are you trying to change it to? Meters. You put that on the top. Now we got to figure out what number goes on top, which number goes on the bottom. Well, how many meters equals how many kilometers? 1,000 meters. Very good. Equals how many kilometers? Just 1. People ask me all the time, does it make any difference where you put the 1,000, where you put the 1? Absolutely. Okay, you have to put the 1,000 with the meters, and you got to put the 1 with the kilometers. Make sense? Because they have to equal each other. It wouldn't make sense to put 1,000 kilometers in 1 meter, would it? Look, 1 meter is this long. I could stretch my arms out to a meter. Could I stretch my arms out to 1,000 kilometers? No, I couldn't even stretch it out to 1 kilometer, okay? So you got to make sure that they equal each other. Now watch what happens. This is very, very simple. The kilometers cancel out. You already told me that. So nothing else is on the bottom. So what do we do at the top right here? Multiply it together. Now look, it's 1,000. Don't pull the calculator out and start putting it into a calculator. You're multiplying by 1,000. It's really easy, especially if a decimal, to multiply by 1,000. So what do? You take that decimal and move it where? Over which way? To the left or right? To the right. We're multiplying. We're making it bigger. We're moving it to the right 3 places, which means, okay, you move it 1 place, it goes here. Then you got to stick a couple what? Couple zeros right here. Okay, Lonnie, you getting all this? Somebody wake him up, please. Okay, get your head up, please. Against the wall. Okay, not against the wall. Sit up straight. Pay attention. All right. I'm not gonna let you just sleep during my class. You kidding me? So it's 4,200 what? Meters. It's all in meters, and that's your answer. Do you see how I did the problem? Look. You always need to write the problem. You need to show your work. And then you need to circle your answer. Okay? That's what you need to do every single time. Okay, if you have a problem where you can actually do some work with it, I want you to write the problem out. So this needs to be on your paper when you write it. Even though it's in the book, I don't care. Rewrite it on your paper. And then you show all your work. This is the work that we showed to get the answer. Get your answer and circle it. That's what you're going to do every single time when you do homework problems for me. Everybody get that? Now, there are times in geometry where it says, tell me what point is next to point B, and you just say point A. There's really no work to show. You don't have to write out that kind of a problem. But if it's a problem like this, you definitely need to work it out. All right? Looking for time here. What's this, 5th period, 12:38? Okay, I got a few more minutes. Let's do another one. Let's go. I'll tell you what. Let's change colors. It's getting a little boring. Let's go yellow. That'd be pretty. Okay. Let's go 17 millimeters. Write this down. 17 millimeters, and I want to change that to meters. It's a little bit different. I'm still changing it to meters, but look, I started with a big number and I changed it to a smaller number. This one I'm taking a smaller unit, millimeters, and I'm changing it to a bigger one. You see that? So your answer might look a little bit different. So let's do this a little quicker than what we did the other one, because we've already done a lot of explanation, so now it's just a matter of doing these problems. First thing I'm going to do, okay, I'm going to put it over 1. Everybody do that. Then I'm going to multiply it by a unit multiplier. So I got to figure out what goes on top, what goes on the bottom. Well, let's look over here. Millimeters is on top. So what am I going to put on the bottom over here? Millimeters. Good. And then what am I changing it to?
Meters.
So where does that go? On the top. Good. Now we got to figure out what number goes where. How many meters equals how many millimeters? What do you think? 100? Milli? What's milli mean? 1,000, right? So does kilo, but where do I put? Do I put the 1,000 here at the meters?
Yeah.
Ah, right. But 1 meter equals what? 1,000 millimeters. All right? They equal each other, don't they? If I put 1,000 meters, think about it. 1,000 meters is huge, big, isn't it? Okay? A millimeter is really, really tiny. All right? There's no way 1,000 meters is going to equal 1 millimeter. So they have to equal each other. Everybody get that? Make sure you think about it. Don't just start writing stuff down without thinking. What happens with the millimeters now? Cancel out. So let's actually cancel them out. Now look what I have. This is not a multiplication this time. What is it? It's division, right? It's 17 over 1,000, right? So what do we do with our decimal when I'm dividing by powers of 10? I move it to the left, right? The decimal normally would be right here, wouldn't it? But if I move it to the left, I got to move it 3 places. So I move it once, twice. What else do I need there? Another 0. So what's my answer going to be? 0.017. Very good. And what's my units? Meters. Right. I canceled out the millimeters and I change it to meters. Now look, that's a very small portion of a meter, isn't it? 0.017. That's 17,000th of 1 meter. And that's what 17 millimeters is. 17,000th of a meter. Does that make sense? That's not hard to do, is it? The explanation takes way longer, but actually doing the problem's not that big of a deal. I've got a couple more minutes. Let me just show you something here. Let's, not done. Not done till I'm done. So let's go down to the bottom again. Let's put this in here. All right, let's look at this. Now, we talked about the metric system the whole time, but we also have the English system. That's what we normally use in the United States. And you know these already, don't you? 12 inches is a foot, 3 feet is a yard, 5,280 feet is 1 mile. Now, that may be a number that you don't recognize. Some of you probably learned it. Some of you maybe didn't learn it. Maybe you were taught it and just don't remember it. All right, but there it is right there. So let's remember that. Let's do some conversions. Let's do an easy one. Let's go 39 feet, and let's convert that to yards. All right? I only got a minute left, so let's go a little quick. 39 feet, put it over 1. Now, what am I trying to get rid of? Feet. I want to get rid of feet, and I want to change it to yards, so I put the feet on the bottom so they cancel out. I'm changing it to yards, so I put yards on top. Here's the tricky part. Okay, how many yards, how many feet? They got to equal each other. So look at it. 1 yard is what? 3 feet. So I put a 1 for the yard and a 3 for the feet. Does it make sense? Okay, you look right up there. Look what happens. The feet cancel out. Now it's 39 not times 3, but what? Divided by 3. Look what we can do. Take the 3. 3 goes into 3 1 time, into 9 3 times. It goes 13 times. If you want to do that on a calculator, you could, but I think that's much better. So what's our answer then? It's just 13 yards. Just like that. It's not hard at all, is it? You should always write this down. Anytime I write something down, anything on the screen, you should be writing it down. Let's try another one. This will be the last one. I don't have much time to slow down. You're going to have to look at it on YouTube if you need to. That's the nice thing about YouTube. So I'm going to change it to miles. MI is for miles. Now look, do I have a conversion that goes directly between yards and miles? No, I got yards and feet, and I got feet and miles, but I don't have one that goes directly from yards to miles, do I? So what am I going to have to do? Don't pack up. I know the bell's about to ring. Don't pack up until I'm done. So watch what happens. 6,600 yards. Okay, the key word was don't pack up. As soon as I said that, I got like 4 people folding their books. Okay? 6,600 yards. I put yards down here. I'm not going to change to miles. What am I going to change to? Let's change to feet. I know I'm going quick, but watch it on YouTube. There are what? 3 feet to 1 yard. Look what happens. The yard cancels out. I got feet. Now I can change from feet to what? To miles. See, I got feet on the top. That cancels out. I got miles right here. Look what happens. The feet cancel out. How many miles, how many feet? 1 mile, 5,280 feet. Good. So now I got miles. What do I do with my numbers, though? Now I would use a calculator. Definitely use a calculator for this. 6,600 times 3, whatever that is, and then divide that by 5,280. Those are big numbers. Use a calculator for that. And then you come out to like 3.75, I think was the number for that. 3.75 miles.
Is that up there?
That's the homework. I haven't showed you anything yet. Okay, it's 3.75 miles. Okay, just wait. Just be patient. I hear you. Okay, just wait until I show you. It's page. Now, for some reason, this is before chapter 1, so they put a P in front of it. It's called P5. It's not just regular page 5. They call it page P5. I don't know why, but it's before chapter 1. And you're going to do numbers 7 to 27. Remember, it's section 01. There it is right there. That's your homework. You're doing all of them. Did I say odd? You're testing my patience. I'll give you double this if you want.